So thank you everyone for joining. My name is Chad, and this is Geospatial Innovations for a Cloud-First World. We've got some exciting stuff to convey in this session. We've got some new tools and features to launch, and we'll dive into some of the key problems that you can solve using those tools and features, and we'll discuss the impact of those solutions to both your business and the world at large. And so joining me for this session are Rebecca Moore, Director of Google Earth and Google Earth Engine, and Andrew Wilcox, the Senior Manager for Sustainable Sourcing from Unilever. And I'm Chad Jennings. I'm a Product Manager in Data Analytics and the Geospatial Lead for Google Cloud. So let's go ahead and get right into it. Google's long been a leader in geospatial tooling and applications, and as we apply that legacy to cloud, our vision is to release geospatial workloads with an exabyte geospatial data lake powered by Google's products and our data assets. And cloud's been bringing this kind of scalable infrastructure to analytics workloads for several years now, and we're doing it more and more and more for geospatial workloads. So geospatial workloads have two primary categories of data. Vector data, and for those of you not familiar with geospatial terminology, you can think of this as any data that would fit in a database table or a spreadsheet. And our geography data type can be any one of these primitives to handle whatever use case you've got. The other type, or the other category, is raster. And so these are visual images, as you see with the 5 of the tiles here, or you can have a data grid, as you see in the top left. And so when we're designing our geospatial cloud offering, we thought hard about the workloads that use these two different categories of data. And we tried really hard to align our products to manage and work with those categories. So for tabular analytics, we have BigQuery's first-class support for geography's data types and PostGIS-like functions. Cloud SQL also supports the same. For imagery analytics, we've got some exciting announcements coming up about Google Earth Engine. It's been available for 10 years as a non-commercial product for researchers and public sector. You know what? Rebecca's going to go into that in more detail, so I'm not going to say any more here. Both of these products are differentiated in their classes. And what's also exciting is that we can make data assets available for your workloads as well. Earth Engine and BigQuery both have extensive catalogs of public data that are curated and ready to go. And additionally, through Google initiatives like Analytics Hub, we're increasing the size and scope of the data ecosystem that you can leverage inside of BigQuery. And so when you combine the capabilities of these products, like serverless data warehousing, embedded ML and AI, and you connect them to the ecosystem of partners and data assets, you really start to make good on the vision that we described earlier. The one missing element is provided by customers and our solutions architects who are using these products to craft specific solutions to the myriad problems confronting their businesses and our environment. So as we speak, customers are using these products to monitor changes in land use, land coverage. Customers are using mobility data, the top right image here, to map how people are moving around cities. Customers are using vehicle telemetry data, the bottom left image, to create heat maps of safe and not so safe areas to drive in a city. And customers are using the bottom right image here. They're using mobile telemetry sensors to create real-time air quality maps that are showing some surprising insights. You see that red blob at the bottom? You can have massive gradations in air quality from one city block to the next. So this image also serves as a visual guide to this presentation. Rebecca and I will talk about the stuff on the left-hand side here. We'll focus on the products. And then Andrew's going to walk us through his particular use case. So let's talk about BigQuery for a moment. We've got a few launches to discuss right here. And over the last year, we've really focused our development effort in two areas. Ease of ingest, so you can get your data into the platform, and a richer set of processing functions so you can do more with it while it's there. I won't go through all of the functions here. You can just pause the video and look, or check the documentation if you're curious about a particular one. But I did want to mention something about ingest. So we're launching now support for GeoJSON files as ingest targets for BigQuery. And when you combine that with the make valid parameter, which is another recent launch, you get a really marvelous capability in that with the make valid set to true, BigQuery will automatically attempt to fix any polygons that don't conform to the OGC semantics. And this applies to GeoJSON or CSV or any format, any file format that BigQuery can ingest. So with these, we're going to make the platform a lot more powerful and a lot easier to use. And in that, I've discussed ingest, implied storage. We've talked about computation. Next one, visualization. So BigQuery is supported by a host of visualization partners, and several of them are depicted here. And to try to make sense of the options, I've broken them down by persona. So regardless of how you interact with the data warehouse, we've got an appropriate viz tool for you. So for example, SQL analysts may choose BigQuery GeoViz, Descartes, or Carto. Traditional geospatial analytics users, we've worked a lot over the last year building better integrations with things like Earth Engine. You'll hear about that in a moment. Esri and Carto also fits into that category. BI users, Data Studio and Looker, and Google Maps developers, you may want to avail yourself of the BigQuery connector available to you through those APIs. And if you've got volumes of data to display, please do take a look at Carto. They've developed a tiling engine on top of BigQuery that can do interactive rendering of millions or even billions of points or polygons. In keeping with the collaboration between Carto and Google Story, we've also done another project together using Google Maps, Google Cloud, and Carto together, and we're launching right now full support for DeckGL in the Google Maps API. So this means that users of the API can leverage the power of DeckGL to create dazzling and immersive renderings of data that come from analyses in BigQuery, including 2.5D hex cell displays, animated bubble maps, full 3D object animations. And with these capabilities that are, like I said, we're launching them right here, right now in this session, you can build more engrossing and informative visualizations for your apps. So with that, I will wrap up for a bit, and I am honored to hand it off to Rebecca Moore. She is a founding engineer on the Google Earth Engine team, and now she's currently the director for the whole product, and she's got some great stuff for you. So Rebecca, over to you.
Hey, thanks, Chad. So to motivate our understanding of the need for geospatial innovation, I wanted to open with this time lapse of deforestation in the Amazon over the past almost 4 decades. This reveals one example of an environmental sustainability challenge that we face. And what's interesting is this type of imagery can be used not only to reveal problems, but also, if we can analyze it, can be used to power solutions. So that sets the stage for Google Earth Engine to help society address these kinds of challenges around sustainability. In 2010, my team developed and launched Google Earth Engine, which was the first cloud-native, planetary-scale geospatial analytics and data platform. We made it freely available to thousands of scientists, NGOs, and other non-commercial users. So a core challenge that Earth Engine addresses is the massive and growing treasure trove of publicly available satellite data and aerial imagery. This type of data historically came off the satellites and went onto tapes in government archives, where it was not very accessible. So our first breakthrough with Earth Engine was collaborating with the USGS to bring the entire NASA USGS Landsat archive, more than 40 years of global imagery going back to the early 1970s, online for the first time on spinning disk in the Google Cloud and accessible for the first time for high performance data mining. So stepping back at the highest level, you can think of Earth Engine as really 2 things. It's a massive data catalog, and it's co-located with an intrinsically parallel computation service. So our goal was to democratize the rather specialized practice of Earth data science and analytics so that many more developers could essentially turn all those raw pixels into actionable information, into knowledge, into applications. So we built Earth Engine from the ground up as a fully managed cloud service where all the data sets are pre-processed into a cloud-native analysis-ready format. We provide an API in JavaScript and Python that contains more than 1,600 purpose-built geospatial analytic functions and a very easy-to-use browser-based IDE for interactive analysis. Our users tell us that really the crown jewel of Earth Engine is the public data catalog. It's today 50 petabytes. It's growing daily. We're growing by more than a petabyte a month. We've got more than 700 carefully curated data sets, and those are also, we're adding more than 100 every year. Most importantly, for certain applications, we are continuously updating these data sets in near real time. So why does that matter? Well, here's an example of the power of continuously updating data. The NASA NOAA GOES satellite is collecting imagery and temperature information about the surface of the planet, so-called hot pixels, every 15 minutes. And that data is continuously streaming into Earth Engine. When you do a Google search today on something like the Dixie Fire in California, Google is now using Earth Engine to determine the near real-time perimeter of that wildfire as it is changing, and then to provide that information to more than 1 billion people using search and Google Maps on any device. And to spur even more geospatial innovation, we have integrated Earth Engine with Cloud AI Platform. You're looking here at a training data set of labeled satellite images by land cover type. Those are training a deep learning model, which can then be applied on new imagery as it is coming into the platform to predict the land cover classes in near real time. And this is really relevant to land managers. We're looking here on the left at the Earth Engine IDE, and on the right, we're looking at an example function applied over a time series stack of satellite images that can sift out all of the clouds and then mosaic all of the cloud-free pixels now into a single cloud-free image. This can be done with one line of script in Earth Engine. So what are people doing with this platform at scale? Well, one of the larger analyses was done by the European Commission Joint Research Center, where they mapped more than 3 decades of global surface water change in high resolution. This is very important for water managers to understand. And the statistics around this reveal why this type of analysis had never been done before, because the scale of it had been impossible. They analyzed, using Earth Engine, more than 3 million Landsat scenes. It was almost 2 petapixels, 2,000 terapixels of imagery data. On a single computer doing that analysis would have taken more than 1,200 years. But because we intrinsically parallelized that for them over more than 10,000 computers, the result was available in just a few days. So the point is you can ask and answer questions with Earth Engine that were never possible before. Hundreds of thousands of scientists are now using Earth Engine. They've published more than 8,000 peer-reviewed publications, really advancing the frontier of environmental monitoring and management of the planet in areas from forest, water, fisheries, agriculture. Basically anything observable from space at scale is now being analyzed using Earth Engine. We've been excited to see now there's been a tremendous pull from government users and private sector companies who want the same power themselves for their operations, for their decision-making. The U.S. Forest Service is one of our early users. Here's an example of an application of mapping change across US Forest Service lands that formerly took 3 months to do. And now with Earth Engine, they can do it with 100 lines of code and an hour. That previous example was showing their application running in our interactive IDE, but often our users are finding they want to then build a purpose-built application. And in this case, we're looking at the land change monitoring system, which is a very advanced forest change detection platform that the Forest Service is putting in the hands of their users. So we're excited, I'm really excited that Andrew's here to talk about sustainable supply chain management. This is a critical frontier for sustainability. And he's focusing today on the palm oil supply chain and using Earth Engine to make that more sustainable for Unilever. But you can imagine this type of thing expanding to soy, cattle, wood, crops, and so on as Earth Engine gets applied in the sustainability space. So I'm very excited that we're announcing today the availability in private preview of Earth Engine for commercial use. We really want to accelerate now the types of innovation that we've seen by the scientific and NGO community, bring that now to public and private sector users. If we're going to address the challenges we face, we need all sectors of society to be empowered to do so. So with that, I'm going to hand it back to Chad and looking forward to hearing from Andrew.
Thank you, Rebecca, and I'm equally excited. This is a marvelous announcement. Thank you for the work that you've done. So please now let me welcome to our virtual stage Andrew Wilcox, who's a senior manager from sustainable sourcing at Unilever. Andrew, can you please take a moment, introduce yourself and Unilever and the problem that we're working on here?
Yeah, for sure. So thanks so much, Rebecca, Chad, for having us here. It's a pleasure to be here. I'm a part of the team in the supply chain that works to ensure that materials in our products live up to Unilever's mission to make sustainable living commonplace. And so the classic sustainability problem is meeting the needs of the present without compromising the needs of the future. But I think we all know we need much more than this. The two biggest crises we face today are climate change and social inequality. And nature has the key for many of the scalable solutions that can mitigate and adapt to climate change while also improving people's lives. And so the problem we face at the highest level is we need a nature positive future, and we need it now.
Okay, so I'm glad we're not trying to solve a small problem here. That's a huge, huge scope. What are the specific aspects that we're getting into?
Yeah. So it's a great question, and it starts with Unilever's 400 plus brands that are used by over 2 billion people every day. And so it's that global supply chain that supports all of that requires that we make sense of effectively the entire planet to ensure that our sourcing matches that mission. And so our specific problem that Rebecca alluded to is with crops like soybeans and palm oil, where we need to be sure we are sourcing deforestation-free material. And so to do this, we need to understand where forests are, how they are changing, how they can be protected, and how they can be enhanced. And we need to evolve from reactive top-down responses into proactive and inclusive local interventions that also has landscapes and communities more holistically than ever before.
And so that's a marvelous and ambitious set of things to do. But as you talk about, interacting with communities, why does, you could have chosen a political solution, or you could, more social, why does a geospatial and a technical solution make sense in that context?
Yeah, indeed. And obviously, comprehensive and holistic solutions are the name of the game. But with geospatial, it's, simple how it plays a role. Our supply chain simply covers millions of hectares of land with tens of millions of hectares of adjacent ecosystems all over the world. And the risk we're managing and the impact we're seeking depends on understanding these many different dimensions of what are very local issues. And so it's geospatial data and cloud technology that gives us the ability to map that and put it on the map and make it visible and interactive in order to extract the right insight that's in the right place and at the right time.
Okay, that makes perfect sense. Like let's press on this dimensions thing, and let's talk about the various dimensions that you're incorporating. And then if you wouldn't mind, as you're describing this, let's also talk about that, like insights at the right place at the right time. Like the temporal processing here, I think, is also important.
Definitely. Yeah. So just, speaking thematically, you could think of the inputs on the left as mostly fitting into either observations or model outputs of what is happening on the planet. So basic things like topography, climate, land cover, but also getting into more advanced derivatives like change detection and prediction, but you name it. And so we draw this from that marvelous Earth Engine catalog that Rebecca was talking about. We also pull it from other public domain sources, and at times we license or commission data directly from partners. And then we take those inputs and apply algorithms and workflows that are effectively in the middle of this diagram to convert those stacks of data into business insights about specific places. And so speaking geospatial for a second, it's band math, it's reducing regions, it's all the raster and vector operations we know and love. And increasingly, more advanced techniques and machine learning techniques. And so, to your point on temporal consistency and where we need to drive action, it really fits into these two categories, assessment and monitoring, both of which that inform how we act. And so assessment is a sort of a priori view where we've got this data-driven understanding of which different geographies can either advance Unilever's mission or conversely pose a risk to it. And then monitoring is where we try and measure if that assessment that we made is holding true, or if underlying conditions, modified and updated assumptions, or hopefully and ideally affections have caused it to change, and then require new and updated action. And so our belief here is that this iterative process of assess and then act and monitor and then act and iterating that at scale and over time will result in a more and more sustainable supply chain.
Well, and it's a complex dynamic that you're talking about. Like we've got multiple layers and multiple dimensions. We've got like temporal constraints because you want to move those insights through fast to do this, assessment and monitoring, like a nationwide scale. Like these images show the current work in Indonesia, but you're really thinking worldwide. And to me, that's one of the things that it's so exciting about cloud, because the tools we're talking about, like BigQuery, Earth Engine, can scale to support that kind of ambition. All right, let's switch directions a little bit here and talk about the intersection of tech and people. You talked about multiple groups of stakeholders, and so what role does technology play in the solution that involves so many different groups of people with so many different agendas?
Yeah, and this is a great question, and really it's the crux of the issue and the challenges we face, because insights are really only as good as their usership. And so that's why we drive the use into our direct operations, but also more and more with our suppliers and our extended supply chain, many stakeholders that share our vision for a nature positive future. And this is where geospatial cloud is truly transformational in terms of making these data intelligible and accessible. And on the one end, you've got kind of business enterprise apps powered by the cloud, integrated with our other business data and processes. And then on the other end, you've got this world, this new world where a basic smartphone is this point of entry for anyone, anywhere to also use these insights for good.
Yeah, and Rebecca showed that in her example with the California wildfires. So like the fact that these insights can be presented to not just folks that are in the geospatial community, but anybody with a cell phone, I think is really powerful. Do you mind if we click into a couple examples?
No, let's do it. Yeah, so good. Here we're looking at that flow we went through, but playing out in a real life sourcing decision. So forget the theory. We're deciding which mills we should source from. And we're located in the lowlands of Sumatra, and we're looking at a palm oil mill. And we're looking at actually the catchment around it and using our understanding of infrastructure to construct what's effectively the footprint of this mill. And then we start enriching this view with data on farmers and smallholders and forests and ecosystems and deforestation and fires and all the things we need to summarize in order to make sense of the world. Whether we're expressing that in administrative boundaries or grid cells or even river basins. And so this gives us that rich assessment of what's happening in this one mill. But what's more important is that we can do this for all the mills everywhere. And understand our overall footprint, which we can then monitor for change and act accordingly.
Right. So this is like the computation portion of the, let's figure out what the insights are, which mills should we be using, what are the parameters that we need to use to decide that. So now let's talk about sharing that.
Yeah, definitely. And this is, I think, where it gets really exciting. And so what we're cycling through here are 3 recent examples coming out of top research groups that use Earth Engine apps to publicly share these critical data on planted palm, where it's planted, deforestation, and forest carbon. And so, these data still require work and further validation and most importantly, stakeholder alignment around the data. But it's that sharing and transparent use of the data that I'm highlighting, because that's what's really starting to mobilize the community, whether it's the geospatial community or the practitioner community, and you're building out this really vibrant geospatial data ecosystem. And we think it's when you pair that community with this ecosystem that unlock collective action. So beyond what any one company or one organization can do. And our vision is for this technology to profoundly alter and really deepen the collaboration towards that nature positive future.
I got to jump in here, guys. Andrew, it's so gratifying and exciting to see the work you and your team are doing. When we dreamed up Earth Engine 10 years ago, we hoped it would be used for this type of application, and you've taken it so far so fast. So thank you very much for the work you're really leading, you're really pioneering in the world. So what's the impact that you're seeing so far? I know it's still early days, and where do you hope that impact is going? And how can you tie that? I'd love to hear a little more about the nature positive theme that you mentioned.
Yeah, so someone who remembers waiting overnight for a Landsat scene to download, the near-term impact here is we have this operational capability to assess and monitor that risk and that impact in near real time for our supply chain and at planetary scale. But the much bigger and more significant impact is catalyzing the transition to what you mentioned there, that nature positive future. And so shifting from drawing down stocks of natural resources and pushing limits of planetary boundaries into a world where we're restoring and regenerating nature while also empowering new generations of farmers. And so, our vision and what we need to do is transform our supply chain to be nature positive, full stop. But to achieve that transformation that can address those 2 crises I mentioned at the beginning requires that basically everyone's on board, all stakeholders are actively included in this journey. And we're just thrilled to embark on this in partnership with Google. This work with Earth Engine and the Geo4Good community are going to play a huge role. And so just to wrap up, I just want to thank you guys so much for having us here. The times ahead are super high stakes, but really exciting and hopeful. And that journey starts now.
And Andrew, I'll throw some gratitude back at, thank you very much for your partnership and your participation here. It's exciting times, and I agree that it starts now. And so both Rebecca and Andrew, thank you so much for joining me in this session today. Thank you so much for the work you've done over the last year, Rebecca over the last decade. I wanted to call out some of the other folks that have contributed to this and work like it. When you take on projects that have this level of magnitude, it takes a village to get the solution completed and landed. So here are some of the partners that have worked on this project, and like I said, others like it, by providing data or functionality or expertise. If you'd like to learn, if you watching this would like to learn more about these launches, the products, or the use case here, we got you covered. So here are some links that you can go to learn a little bit more. And with that, on behalf of my presenters and myself, thank you very much for your attention. Thank you for your time. Take care.